Hi, my name's Mrs. Wright, and I'm with the American Museum of Science and Energy. And today we're going to do an experiment with something that you probably had for breakfast this morning. I know Caden had a good cup of plastic for breakfast, right? No, but we're actually going to make plastic out of milk. And a lot of you probably had milk for breakfast this morning. And in order to do this experiment, you're going to need some type of container like a mason jar or a coffee mug, something that can hold a hot liquid. You'll heat 1 cup of milk for about 1 minute, preferably whole milk because it has a lot of casein proteins in it and fat. You need another mason jar that you can put a sieve on because it's going to help catch our solids, our plastics that we're going to create. You're also going to need vinegar, about 2 teaspoons of vinegar. And if you want, you can also get some food coloring to color your plastics. After you make your plastic, if you leave it in a cup covered in vinegar and some food coloring, let it soak for about an hour, it will absorb those colors. So we're going to get started, and the first thing we're going to do is let Caden put his vinegar inside of our mason jar real quickly, and he's going to add his hot milk and pour it in, and we're going to see some milk magic. We're going to have a chemical reaction with the vinegar, which is acetic acid, and the casein, the proteins and fat that is in the milk. We'll give it just a minute to start working, and then we'll show you what's beginning to happen. Milk in its natural form carries a negative charge. Since 80% of the proteins in milk is casein protein, it carries a negative charge too. Usually these protein molecules are folded up, but when the vinegar is added to the heated milk, the pH changes to about 4.6, and the positive ions in the vinegar neutralize the negative charges in the casein micelles, and they start to unfold and begin to group together and rearrange into a long polymer chain. The solid that's formed from these long polymer chains is what we see. It's called curd. These polymer chains do not dissolve in water and can be molded into different shapes. In other words, they form an organic plastic, what we call bioplastic. Now that we've had our reaction, we're going to filter our curds in whey, or our bioplastic in whey. You'll see that it's starting to filter, and the liquid contains most of the whey, and the curd has the casein and the fats. That's what's actually going to make our milk plastic. Go ahead and pour the rest of that in there. So you give it just a few minutes, and you can move your curd around a little bit and let that liquid start going out. We'll take it and unscrew the lid. Then you can lift your bioplastic up a little bit. You can squeeze out any remaining liquid you might have in there and get paper towels ready to help dry it off a little bit more. Now your milk plastic is going to be white. You pat that down, you can flatten it out, and you can cut different shapes out. If you have cookie cutters at home, you might want to cut out star shapes or angel shapes. Good job. I'm going to just roll it out on our cutting board, press it out, and you can cut different shapes. Now, if you want the plastic to be a little bit smoother than what we have, you can let it sit for about an hour in food coloring and vinegar, and it will absorb some of the coloring. And Caden, if you'll show them some of the different bioplastics we've made already. We made some ornaments, and as you can see, they're hard. If you tap them on something, you'll actually see how hard they are. So as you can see, it gets nice and hard. It's our butterfly in different shapes. Now that we've experimented with bioplastics at home, we're going to head to the museum and look at how we use bioplastics in the museum setting. We're back at the American Museum of Science and Energy, and we're looking at one of the ways that we use bioplastics in the museum. We use what's called a PLA filament for our 3D printers. And PLA filament is basically a cornstarch based filament. We make a lot of our items that we sell in the Discovery Shop for souvenirs out of the PLA. And we also have a 3D printing exhibit out on the main floor, which includes a full-size Jeep. Bioplastics can be used for many things, and one of the main things is a 3D printer. However, 3D printers can use a lot of different mediums, and we encourage you to come by the museum, check out the exhibit, and look at how we use 3D printing on an industrial scale.